All right, we're in geometry, 8-3. Today's date is the 5th of March. Oops, I need to go up here to my writing utensil. Today's date is the 5th of March, so it's 3/5. Write down the date on your paper. There's a lot of side conversations happening right now. All right. Do you need a pencil? All right, guys, you're a little bit too much for me already. There's a pencil. If there needs to be a fight, there's a pencil. All right, so radians. How many of us have heard of radians by show of hands? Only a few of us. And how many people, by show of hands, can explain what radians are? Yeah, so radians are a unitless measure. Unitless measure. So when we talk about how far things are, we talk about how many feet they are, how many inches things are. When I'm talking about radians, radians are unitless. It's this very mathematical idea where we don't have to worry about units. It's this really nice idea. So if I'm talking about radians, usually it's going to be talking about an angle, but radians can also be a length as well. But actually, no, that's wrong. So it's an angle. Let's write that down. It should be an angle. So if I'm looking at this circle, let's say I start at this spot right here. Usually this is where you always start on a circle. You start at the farthest right, unless you're doing navigation. I guess if you are talking about a compass or something, you might start at the top. But in mathematics, for the rest of your careers, for high school and college, you're going to start on the circle at the far right side. If you're thinking about the x-axis is 1 over here. All right, so if I go from this point and I have this angle from here all the way over here, this 360 degrees, we're not in degrees anymore. We're in radian land. In radians, this is 2 pi radians. This angle here is 2 pi. I say radians, but I can just say 2 pi, and you can assume it's in radians. If I don't have a unit, if I don't have this little degrees in the top right, then it's in radians. Knowing whether it's in radians or degrees will affect everything that you do in terms of your mathematics. In fact, if you take out your calculator, if you pull out your phone right now, if you pull out your phone and you pull up your calculator, I can pull up my calculator on my computer right now. Yeah, you gonna grab some? You'll notice in the bottom left-hand side, you have this RAD button. That is because your calculators are programmed to do radians or degrees. Right now I'm in radians. Now I'm back to degrees. So the math is different for radians and degrees. Does everyone see that they have radians and degrees on their calculator? So make sure that when you're doing the math for this lesson, and when you see this on a quiz or a test, pay attention if it's in radians or degrees. All right, I might have to split up this group if this continues on for much longer. All right, so let's talk about how to convert from one to the other. If this was 2 pi radians, that's also the same thing if I'm talking about degrees as 360 degrees. So if I set up a ratio, my ratio would look like this. My ratio would be 360 degrees. Notice that I have a unit up here. 360 degrees divided by 2 pi radians is equal to 1. These are the same thing. 2 pi is the same thing as 360 degrees. Can't say words. Degrees and radians. This is how I'm going to convert back and forth. If I simplify this ratio can be simplified to what? Quiet raised hand. I can divide the top and bottom by a number, get it to just pi. What can this be reduced to? 360 over 2 pi. Colby. I'll take it. And you get 180 degrees divided by pi. And that special fraction is what we're going to be using over and over again. So say I have an angle in degrees. I'm over here on the right hand side. I have an angle in degrees, but I want to get it to angle in radians. In order to get rid of degrees, I have to put degrees on the bottom. In order to get rid of degrees, I'm putting 180 degrees on the bottom. Write it down. 180 degrees on the bottom. And then on the top, I need to convert to radians, so radians is going to be on the top. If I want to go the other direction, if I have radians, I need to get rid of radians. I get rid of radians by putting radians on the denominator. Radians is now in the denominator, and I'm going to convert 2 degrees, so degrees is going to be in the top, 180 degrees. Oops. So now we have a formula to convert back and forth between radians and degrees. Let's see if we can use this. We're coming down here to example 1. All right, I have radians. I want to get 2 degrees. How do I get to degrees? Quiet raised hand. What am I going to do? I see one hand. No one else?
That's what happens when you miss an opportunity.
2 hands. How do I convert degrees to radians? Sorry, radians to degrees. I have radians. I want to get 2 degrees. Jaden, go for it.
I'm assuming I put the degrees on the bottom.
So I want to convert 2 degrees. So I'm trying to get angle in degrees, right?
I thought I was going 2 degrees.
Yep. So I need degrees.
Okay, so that's on top.
Okay. 180 degrees on top.
Yep.
What goes on the bottom?
The 0 thing.
The 0 thing. Pi. There it is. And then I'm going to multiply that by whatever angle I was given. The angle in radians, angle in radians.
Oh, I thought we were doing 135. In that one. So
Okay.
this example 1.
We're on example 1, yeah.
Then we're doing 8 pi over 9.
There it is. What do you see on the top and bottom that can be canceled out?
Pi's.
Pi's. Everyone cross them out. Cross out the pi, cross out the pi. You can cancel it out. All right, what other things can I reduce? Jane, do you see the 189? Can those be reduced at all?
No.
They can. All right, I'll take your card.
I don't know.
How can I reduce this fraction?
Realize that he did. No, I didn't say that.
Ellery, go for it.
Well, 180 divided by 9 is 20. So you would have 1 times
Or yeah, so if you
or 8 over 20, yeah.
So if I cross off 180 divided by 9, I'm crossing both these off and I'm saying 180 divided by 9 is 20. This turns into a 20, that turns into a 1. So from there, I'm just going to multiply straight through. This is gone times 1. I have nothing in the denominator. On the top, I have 20 and 8. 20 and 8 is 160. And notice that the thing that I have left over for my units is degrees. 160 degrees. There it is. Thank you. All right, let's try going the other direction. I'm going to go the other direction with example 2 now. It's going to be very, very similar to example 1, just using the other formula. All right, now I have degrees. It has this degrees in the top right. I need to convert 2 radians. What am I going to do with my angle? I'm going to start with 135 degrees, and what am I going to do with it? Quiet raised hand. What am I going to do to this degrees? I see one hand, doesn't have a card though.
Can I give the swings and see?
I see 2 hands, still no cards. I want to try to open it up to more people if possible. Yeah, go for it, Anna.
So you put pi on top of the 135 on the denominator.
Careful, it's going to be the same ratio just from our formula. So pi does go on the top. I'm going to multiply by pi, and what goes on the bottom? 180. Pi is the same thing as 180 degrees. What I'm really doing here is I'm multiplying by 1. This pi over 180 degrees is 1. So I'm really multiplying by 1. I'm not changing the angle at all. Notice that I have degrees on the top and degrees on the bottom. I literally cross off just the unit. Cross off the degrees, cross off the degrees. I'm left with just no unit. I'm left with radians. Now I have to simplify 135 over 80, and I still have pi in the numerator. How do I simplify 135 over 80? What can I divide the top and bottom by?
21.
What common factors does 135 and 180 have? What can I divide the top and bottom by? Who said 5? Beverly? Yeah. Jaden? Someone? All right, yeah, divide the top and bottom by 5. Divide by 5, divide by 5. When I do that, well, 100 divided by 5 is 20. 35 divided by 5 is 7. So 27 on the top. And on the bottom, 180 divided by 5 is 36. So I'm left with 27 pi over 36. I can still reduce this fraction. What should I divide the top and bottom by now? 3? Ooh, I could even do 9. That would be even faster. Let's do 9. 27 divided by 9 is 3, so I'm left with 3 pi. And on the bottom, 36 divided by 9 is 4. 3 pi over 4. Box it. Beverly, I'll take the card. Thank you so much. All right. That's the first half of the lesson. Just converting back and forth between degrees and radians. The second half is using our new arc length formula.
9/4 was the answer.
9/4 was not the answer. Our answer was 3 pi over 4.
Same thing.
All right. On the left, we have review. To find arc length, what were our two ratios that we set equal to each other to find arc length? It was something divided by 360 equals something over something. You guys remember this one? Who remembers this? By quiet raised hand. Martine, go for it.
So on the right, isn't it arc length?
It is arc length. Yep. Arc length. GTH over circumference.
On the left, it's theta over 360.
It is indeed theta over 360. Thank you. Oop, what happened there? Theta over 360. Thank you, Martine. I'll take the card. All right. That was our old formula. That's the formula when we are in degrees. Now we're in radians. So now we have a new formula. And it's even easier. Now we just have theta on the left. No divided by 360. Theta is equal to arc length. Arc length. Why is this messing up so much? Arc length divided by radius. Wow. Board is not working. Arc length over radius. It's an easier formula to use. Let's see an example when we're going to use this formula. The next few examples are only using this right-hand formula. So when I ask you what's the formula, come back to this star. We're going to be using it over and over again. All right, we're on the back. Flip it over. Example 3. I need to find theta. All right, this is an easy peasy question. Someone regurgitate the formula. Someone tell me the formula. Leo, go for it. Over radius. Thank you, Leo. I'll take the card. Oh, you didn't get a card? Weird. Okay. Weird. Oh, there is a second half. All right, Leo, I turn in your card. I have Cheyenne, Adzuri, Oscar, Caroline, and Emily's card up here. All right, so now that I have our formula, thank you, Leo, what am I going to do? I'm going to fill it in with Samantha.
It's theta
All right, I still have theta.
equals, arc length is going to be 12.
12
And the radius is going to be 6.
over 6. All right, can you reduce 12 over 6 for me?
Oh, it's just 2.
2. There's our answer. Aren't radians so nice? Done. That's how easy these problems are. Radians usually make your life a lot simpler. Usually. All right, we're on to example 4. All right, so now I need to find the fraction of the circumference that we're taking up with our arc. All right, so this is going back all the way to the first part of your notes. I need to know how many degrees were there in an entire circle in radians. In radians. All right, and I know that the numerator is going to be 2 pi over 3. So it's going to be 2 pi over 3 divided by the total angle. That's going to give us the fraction. So the fraction here, let's write out the general formula. Fraction is going to be our angle, our theta, divided by the total. All right, so therefore, our fraction is going to be equal to, why is the menu not working? All right, is equal to, well, our theta is 2 pi over 3. So let's fill that in, 2 pi over 3. Come on now, 2. All right, I'm abandoning. It should be 2 pi over 3. I'm going to come back here and sit down and use this because and then what was the total? I need a quiet raised hand. What was the total angle? I see one person that knows. What was the total? Go all the way up to the beginning part of your notes. The total angle. Ellery, go for it. So that's in degrees.
Oh, 1 pi over 20.
So how many radians are there in a circle?
2 pi.
2 pi. 2 pi. Everyone write it down. The total is 2 pi. Everyone is copying this down. This is one of those keep it, change it, flip it things. So I'm going to keep the top. The top was 2 pi over 3. So I'm just coming down here to a new line. The top was just 2 pi over 3. The bottom is 2 pi over 1. So I was dividing fractions. So this is keep it, change it. So the change of the division is now turned into a multiplication. So keep it, change it, and now I'm going to flip it. Instead of 2 pi over 1, I'm going to take the reciprocal. Instead of 2 pi over 1, I have 1 over 2 pi. All right, quiet raised hand. What do I do from here? How do I simplify this? Quiet raised hand. Chewy, you want to give it a shot? Yeah, how do you simplify? What do you cross off? I can cross off the pi's, yes. What else can I cross off? The 2's, yes. And I'm left with what, Chewy? 1 over 3. There's the answer. Thank you, Chewy. And our final example. Our final example, example 5. I need to find the length of S. So again, I need that formula. The formula from the front side of the page, the one that we started. Easy participation points. Someone repeat the formula for us. Start with the formula. Who can do it for us? Just regurgitate that formula. Not one of us will do it. Oh gosh. Go for it, Anna. Arc length, GTH, over the radius. Thank you, Anna. From there, I need to fill in everything that I know. Another quiet raised hand. Who can fill in the stuff that we know from this diagram? Only one person. 2 people. All right, go for it, India.
It would be 2 theta. Then it would be S over 3.5.
There it is. Our angle was 2. Our arc length was S. And finally, our radius was 3.5. We just fill in each of those things. Thank you, India. And then finally, what do I do to solve for S? Right now, S is being divided by 3.5. To solve for S, what am I going to do to both sides, Beverly? Multiply by 3.5 on both sides. 3.5. And that will cancel out the 3.5, and I'm left with S is equal to 2 times 3.5. S is equal to 7. Final answer. Box it.
S equals 7.
Yep, 2 times 3.5 is 7. That's all I have for you guys. Go ahead and write your summaries, and then you can begin on the 2 homework assignments that we have on Khan Academy.